right, write each fraction in simplest form, 30 and 35. 5 goes into those, so 5 goes into 36 times. Let's see if it'll let me write. Okay. Eventually that'll show up. Maybe. There we go. Now it all shows up. Okay, all right. So 5 goes into 36 times, 5 goes into 35 7 times. 24 and 40 are both divisible by 8. So 24 divided by 8 is 3. 40 divided by 8 is 5. 54 and 60 are both divisible by 6. 54 divided by 6 is 9. 60 divided by 6 is 10. And 12 and 15 are both divisible by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. All right, today we're talking ratios and unit rate. Ratios is just a way to compare numbers. Typically it's seen as a fraction. You could also write it as like 10 to 15. That would be comparing those two. Sometimes you'll see it with colons between it. It all means the same thing. But really the way you're going to see it the majority of the time is 10 over 15. And then you would just reduce that. So a survey asked students whether they had after-school jobs. Write each ratio as a fraction in simplest form. So let's look at the chart here. Students that have a job, there's 40 of them. Don't have a job, there's 60. Altogether, there are 100 students in this survey. So they want to compare the students with jobs to students without jobs. So 40 of them have a job compared to the 60 of them that do not have a job. And then we just need to simplify this. Now, these both end in 0, which means they're both divisible by 10. So we can just knock off one of the zeros, aka divided by 10. And then you're left with 4/6, which are both even numbers. So we can cut those in half. They're both divisible by 2. So it would be 2/3. So 2 students with jobs to every 3 students without a job. I'm going to scoot over here. Students without jobs to all students surveyed. Let me move that up. Students without jobs to all students surveyed. So how many students do not have a job? There's 60 of them. Oh my goodness. Oh my goodness. Compared to the 100 students surveyed in all. Again, these both end in 0, which means they're divisible by 10. Thank goodness we did that divisibility section to make this stuff easier. So now we're left with 6/10. Those are both even, so we can divide it by 2, which would give us 3/5. Great. So 3 out of every 5 students do not have a job there after school. Oh, these are the same questions that go with the same chart. So let me see if I can scooch this up over so we can still see the chart. You know what? I'll just move the no, I won't. Oh goodness. Let's erase this. Make some room. Make some room, boys. Come on now. There we go. There we go. Students with jobs to all students surveyed. So it said that 40 of them have a job. There were 100 surveyed overall. Simplifying it, we can knock off a 0 for a 0. 4/10, divide them both by 2, which would give us 2/5. Students without jobs to students with jobs. Well, students without jobs was 60. Students with jobs was 40, and I gotta sneeze. Knock off a 0. 6 and 4 are both divisible by 2, so that would be 3/2. There we go. There we go. A unit rate is when you're comparing them, but there's a denominator of 1. So you really just have to divide it. So let's look at this. And this is something that you'll see at the store. So if you go to Walmart or something, they actually put the unit rate on the label there with the price. So it'll say like price per ounce. And then that's a pretty easy way that you can determine what's the best deal. So the table shows prices for different sizes of the same dish detergent. Which size has the lowest unit price? So let's calculate the regular. Anytime you're dealing with money, the money will go in the numerator because you're always looking like the cost per pound or cost per ounce. So the regular one, we're going to say $1.20 divided by 12 ounces. So when you divide 1.2 divided by 12, you come up with 0.1, which means in realistic terms, 10 cents per ounce. So that would be the unit cost of the regular size. The family size is a little larger, a little more expensive, so it's 224 divided by, that one's 28 ounces. So let's calculate our cost per ounce there. 2.24 divided by 28. So that one comes out to 8 cents per ounce. So that's a better deal so far. And then let's figure out the economy size. Whoa, we go. That one is 360, and that is for 40 ounces. So if you do $3.60 divided by the 40 ounces, it comes out to 9 cents per ounce. So the best deal would be the family size. Most of the time, it's interesting because most of the time, the larger you buy, when you buy in bulk, it's usually cheaper per ounce. This one, they're just trying to throw us off here. I don't know. It's not always that way. Sometimes with toothpaste, it's weird. You get bigger ones that it's not even a better deal. But you're putting less packaging out there, I guess, so that's good. 2 liters of spring water costs $1.98. So finding the unit rate would be what's the cost per liter. So we're going to say 198 divided by the 2 liters, and that will give us 99 cents per liter. A car goes 425 miles on 12.5 gallons of gas. Now, you often hear miles per gallon. You're not going to say gallons per mile, right? Because you're not going to need multiple gallons to go 1 mile in a car. So we're going to go miles per gallon here. So we'll say 425 miles per 12.5 gallons. And if we divide that, 425 divided by 12.5, we get 34 miles per gallon. It's pretty efficient. You should go for fuel efficiency, unless you need a big old pickup truck for doing your job or something, then that's all good. That's great. If you don't, then come on, let's save some gas. Convert 10 miles per hour to feet per minute. We're going to write 10 miles per hour as a fraction. 10 miles per 1 hour. Okay, now here's the deal. You cancel out stuff in a fraction by putting it in the numerator somewhere and the denominator elsewhere when you're doing multiplication. So we don't want the miles and we don't want the hours. So if I'm trying to get rid of miles, and it doesn't matter which one we get rid of first, it's in the numerator up here. So if I'm trying to cancel out miles, I'm going to put it in the denominator. So we're trying to go to feet. Now, I don't expect you to memorize how many feet are in 1 mile, but 1 mile is 5,280 feet. So check out what happens. We can cancel out the units then. We'll cancel out miles for miles. Our only unit up top is feet, and on the bottom is hours. So we're in feet per hour right now. We need it to be feet per minute. So we don't want hours. It's in the denominator right now. If we don't want it, we're going to put it in the numerator. Now, this you probably do know. Minutes and hours. 1 hour has 60 minutes. So if we cancel out those units, we cancel out our hour in the denominator for our hour in the numerator. Now our only unit left on top is feet. our only unit left in the denominator is minutes. So we have it in feet per minute. We just need to do the actual math for it now. So up top, 10 times 5,280 would be 52,800 feet per 1 times 1 times 60 is 60 minutes. And then we can just divide it to get that unit rate. So 52,800 divided by 60 is 880 feet per minute. So that's pretty challenging. Just remember, when you're canceling out units, put it on the opposite side of the fraction. If it's in the numerator, get it in the denominator somewhere else. So now we're going to solve proportions. You're going to be great at this. It's not too bad. You just cross multiply and you solve for x. So my man Gary Goldman's got a great bit that talks about proportions. So it's when you have one fraction equals the other fraction. There's an equal sign between them, so you multiply it diagonally. So we're going to do 6 times x, which is 6x. And we're going to set that equal to the other cross products, which are 4 and 9. So 4 times 9 is 36. Now we just need to solve that equation. 6x equals 36. You just divide by the 6, you end up with x equals 6. That's it. That's it, bro. Cross multiply, solve for x, or whatever variable, I guess. So here, if we multiply diagonally, h times 3 is 3h. Set that equal to 9 times 2 is 18. So we'll divide by the 3 on both sides. And 18 divided by 3 is also 6. They don't all work out to 6. This is just a coincidence. So it doesn't matter the order you do it in. So 4 times 55 is 220 equals 5 times t, 5t. We'll divide it by the 5, which will give us 44 for t. T equals 44. All right, over here, woo-wee! 6 times d is 6d. I don't know what 22 times 21 is. 462, like I said. We'll have to divide by the 6. 77. D equals 77. There's also another way you can think of it, if this is helpful. If we look, and it's easy numbers to work with, like 5 to 55 is times 11. So if you did that up top too, 4 times 11 would give you 44 up there. I would only recommend that if it's like very obvious numbers. If it jumps out at you that you see that pattern, great. Otherwise, cross multiply. You'll make less mistakes if you do that. Now, do the ratios 4/6 and 10/14 form a proportion? Explain. Well, we're going to set them equal to each other, and we'll see if the cross products are equal. Or you can simplify each side and see if they come out to the same fraction, but that's honestly more work. 6 times 10 is 60. 4 times 14 is 56. Does 60 equal 56? No. So we would just say no, because the cross products are not equal. And part of the definition of a proportion is the cross products are equal to each other. That's how we're able to solve them, because we know they're equal. All right, and then word problems. Story problems typically terrify humans. I understand. I have nightmares about story problems. It's like, if I only have 4 hours left to sleep and I have to wake up to go to the bathroom twice, right? It's scary. But these are actually nice because you can set it up myriad ways and be fine. As long as you're consistent with the order. So 100 nautical miles equals about 115 standard or statute miles. To the nearest mile, how far in statute miles is 156 nautical miles? Okay, We're setting up a proportion. Again, as long as you are consistent with the order you set it up in, you're fine. So look at the first sentence. 100 nautical miles is about 115 standard miles. So I'm going to put my nautical miles up top, and I'll put my standard miles on the bottom. So that would be 100 nautical miles for the 115 standard miles. Now, if we did nautical over standard on that fraction, then on the other fraction, we would also have to do nautical over standard. So it says, let's see the rest of it. How far in statute miles is 156 nautical miles? So it's nautical, it'll go up here. We're looking for the statute miles. So this is our unknown. So let's just call it x. Now when we cross multiply here, we don't need the labels. We're doing 100 times x, which is 100x. We're setting that equal to 115 times 156. I don't know what that is. 17,940. So we solve it by dividing by 100, which means we're moving the decimal 2 places to the left, knocking off a couple zeros. So that would be, did I multiply that right? I think I added too many zeros there. Oh yeah, I did add too many zeros. Whoops. So this would come out to 179.4. Now it says to the nearest mile, so we'll say 179 statute miles. All right, so that's it for proportions. Now the next section we're doing pretty much only word problems. So it's pretty darn fun. Get excited. Let me make sure. Is that my last slide? Yep, okay.